Here is the key to your review. All right, so the first one's for each of the following, write an equivalent expression using a single logarithm. All right, so if I'm subtracting two logs with the same base, turns into one log with division. There we go. All right, so here I'm subtracting. So remember, if you have more than one term, everything that is positive can go in the numerator, and everything that you're subtracting will go in the denominator. But before I do that, I got to make sure that this 2 becomes an exponent, and so does this y, which means I will get x squared in the numerator, and then 3 times y to the 5th in the denominator. Okie dokie. Which of the following expressions is equivalent? So we're basically doing the opposite of what we just did. So this is the natural log, all right? I have 3 things that I can break it up into, and I'll do this in a couple of steps just to make sure I don't lose anybody. The stuff in the numerator, natural log of 2 plus the natural log of x cubed minus the natural log, and the square root of y is the same as y to the 1/2 power. Okay, so now now it says which of the following is equivalent. What I have right now does not match up over there, so I need to go a little bit farther. Natural log of 2 is just natural log of 2. This 3 comes out front, and then the 1/2 comes out front. And there we go. And so that natural log of 2 is the 3 natural log of x, so I can eliminate that one, minus 1/2 natural log of y. That is B. Alrighty, number 6. Which of the following expressions is equivalent to this? So we're going to do the same type of thing. This is log base 2 of 8 plus log base 2 of x minus log base 2 of y cubed. All right, so some of us struggled with this one. Some of us got here. We were able to get then to log base 2 of 8 plus log base 2 of x minus 3 log base 2 of y, which made this a very popular answer. That is not the answer because 8 and log base 2 of 8 are not the same thing, okay? And notice that then we have this. That's not going to be the same thing either. And so it looks like I got to do something with this log base 2 of 8. Remember, log base 2 of 8, I can rewrite that as log base 2 of 2 cubed, which is just going to give me 3. So then I can change this to 3, and my answer is B. Alrighty, number 7. Which of the following is equivalent to this, where x and y are positive constants? So I need my 4 to become an exponent. I need my 1/3 to become an exponent. And then this is the log. Everything that's positive goes in the numerator, so that is x to the 4th times y to the 1/3, and then 4 in the denominator. So that looks like that should be B. All right. Next page. So this time we are solving. We've got to show all of our work and be sure to check for extraneous solutions. So remember, we can have extraneous solutions with logs. So I got to find my domain here. X minus 1 has to be greater than 0, which means x has to be greater than 1. That's my domain. Okay. Then I can solve this. I'm going to rewrite it to 10 to the 2nd power equals x minus 1. So that's 100 equals x minus 1. So x equals 101. That is greater than 1, so that is my answer. Number 2, I need 2x to be greater than 0, so x has to be greater than 0. Now, I have a couple of options of what I could do. I could let 4 become the exponent here and rewrite 3 to the 8th power equals this, but I don't know that I really want to do that. Since I have another option, I can divide both sides by 4 and get log base 3 of 2x equals 2. Now if I rewrite it, 3 to the 2nd power equals 2x. So that means when I divide, I'm going to get x is equal to 9 over 2. And 9 over 2 is greater than 0, so I'm good. Excuse me. All right, on number 3, x over 3 has to be greater than 0, so x has to be greater than 0. All right, so I'm going to subtract 4 from both sides. Natural log of x over 3 equals 3. So then I can rewrite it. The base of a natural log is e, so e to the 3rd power equals x over 3. Then I can multiply both sides by 3, so x equals 3e cubed. Even if you have no concept of how much 3e cubed is, you should know that it's greater than 0. So you're good. All right, number 4. Got 2 things I got to check here. These 2. So x has to be greater than 0, and x minus 4 has to be greater than 0, so x has to be greater than 4. This guy wins. All right, so I'm going to condense these 2, and I don't have to write the base 10 on there, so log of x over 3 is equal to the log of x minus 4. Then I can drop the logs and get x over 3 equals x minus 4. So x is equal to, when I multiply through, 3x minus 12. So negative 2x equals negative 12. X equals 6. 6 is greater than 4, so I'm good. All right, so over here I've got 3 things to check. X plus 2 has to be greater than 0. So x has to be greater than negative 2. X minus 1 has to be greater than 0, so x has to be greater than 1. And 3x plus 13 has to be greater than 0, so x has to be greater than negative 13 over 3. So it looks like this guy here wins. All right, so I'm going to condense these 2, so this is going to give me the natural log of x plus 2 times x minus 1 equals the natural log of 3x plus 13. So I'm going to drop the logs, and when I do that, I'm going to go ahead and multiply these together and get x squared. So it'll be plus 2x minus x minus 2 equals 3x plus 13. That is a quadratic, so I'm going to set it equal to 0. So x squared minus 2x minus 15 equals 0. Factor x and x. That will give me a negative 5 and a positive 3. So I get that x is equal to negative 3 and 5. But I have to be greater than 1, so that one does not count, and it's just x equals 5. All right, next one. I can condense the left, so this is going to become log, oops, let's see, before I do that, I thought I was changing colors there. Before I do that, I want to check these. So 4x has to be greater than 0, even if I didn't do it first. As long as I actually do it, it would be fine. X is greater than 0, and then x minus 2 has to be greater than 0, so x has to be greater than 2. This guy wins. All right. So now I can condense these. Log base 2 of 4x over x minus 2 equals 3. I do not get to drop logs here because I don't have a log on each side like I had on some of the others. Here I'm going to rewrite this. 2 to the 3rd power equals 4x over x minus 2. Okay? So I'm going to do two things in one step. 2 cubed is 8, and I'm going to multiply both sides by x minus 2. So that's going to give me 8x minus 16 equals 4x. So negative 16 equals negative 4x, and x equals 4, which is greater than 2, so I'm good. All right, let me check these. So here, x has to be greater than 0, and then 2x plus 13 has to be greater than 0, which means x has to be greater than negative 13 over 2. This guy wins. All right. So now on the left, I'm going to condense it, but I have to pay attention to this 2. I don't get to divide like I did on the other one because I don't just have a number on the other side. So he is going to have to become an exponent. So this is going to give you the natural log of 3 squared times x equals the natural log of 2x plus 13. Okay? So the x is not squared, just the 3. So now I can drop the logs, and I'm going to get 9x equals 2x plus 13. 7x equals 13. X equals 13 over 7, which is greater than 0. That's my answer. Alrighty. So here, I want to solve f of x equals 1 for values of x in the domain of f. Alright, so that means I'm checking my domain here. That means that x minus 3 has to be greater than 0, so x has to be greater than 3. All right, so I'm going to want to let f of x equal 1, so that 1/2 times the log, and it's base 10, so I don't have to write it, of x minus 3 is equal to 1. All right, so now I'm going to solve this before I could make that 1/2 a power on my x minus 3, but I can also just multiply both sides by 2, so I can get the log of x minus 3 equals 2. Now I can rewrite it. The base is 10, so 10 squared equals x minus 3. 10 squared is 100. I add 3. X equals 103, which is greater than 3, so I'm good. And then I'm going to do the same thing here, but for g, well, not the exact same thing, I guess, same kind of thing. I've got to check my domain here, so x plus 2 has to be greater than 0, so x has to be greater than negative 2. Then I want g of x to equal 8, so 3 times the natural log of x plus 2 equals 8. All right, so I'm going to divide both sides by 3, or it can become an exponent, but I think I'd rather divide. So I'm going to get the natural log of x plus 2 equals 8/3. Then I'm going to rewrite it. My base is e, so e to the 8/3 power equals x plus 2. So x equals e to the 8/3 minus 2. And you may not like e, but e means easy, right? If e was an actual number, I might actually need to do the 8/3 power, but not with e. Again, you may not really know the exact value of this, but e to any power greater, so e to the first is 2.7 something. So even just plain old e minus 2 would still be positive. E to any exponent greater than 1 is all that's definitely going to be positive, and I only have to be greater than negative 2, so I think we're good on that one. Alrighty, next page. Okay, they give us j and k. We want to rewrite it as a single natural logarithm without negative exponents in any part of the expression. Okay, so j of x equals, so this 1/3 is going to become an exponent, the 4 is going to become an exponent. That's going to become 1 log with division, x to the 1/3 power, and y to the 4th power. And whether you leave it like this, or you say the natural log of the cube root of x because it just says not negative exponents. Fractional exponents are okay right now. Either one of these is fine. All right, so then B, we're going to do the same thing with K. So 3 is going to have to become an exponent. This one doesn't need one, and that one doesn't need one. So K of X is equal to, all right, so we're going to have the log. We're going to get a fraction. Everything positive goes in the numerator. So this is going to be x plus 2 to the third power. X goes in the denominator, and a 5 goes in the numerator. And we're done. Okay. Function k is given by this. Solve k of x equals 7e. This is k of x for all values of x in the domain of k. This is exponential, so the domain is all real numbers. So I just need to do 2e to the 3x power minus e equals 7e. All right, well, I can't combine these two. This isn't a log, so that's no rules there, but I can add e to both sides, so I get 2e to the 3x power equals, and when I add e to both sides, that'll give me 8e. Now I can divide both sides by 2 and get e to the 3x power equals 4e. Right? Now, I cannot rewrite this as a log, or I'm sorry, I can. I cannot just drop the e's because I have something in front of e here. So that doesn't work, and it doesn't become an exponent because we're not in the log right now. But I can take the natural log of both sides. So when I do that, and I get the natural log of e to the 3x power equals the natural log of 4e. Well, the natural log of e to the 3x power just becomes 3x. And then that's equal to, I can split this, the natural log of 4 plus the natural log of e. And then the natural log of e becomes 1. So when I divide, I get x equals the natural log of 4 plus 1 over 3. Alrighty. So then I want all the values of x for which this is true. So here I think I can get common bases, and I think maybe I will do it in, well, I'll just do it in one step. So I know I can get a base of 2 on both of these. You could also do 1/2, but I don't think most of y'all would like doing that. So I know 8 can be 2 to the third, and then that's to the 2x plus 1 power. Okay, and then my base of 2 over here. And then since it was 1/4, I know 2 squared is 4, but I need that to be a negative 2 because it is the reciprocal. So then I'm going to do one more step just so that I don't lose anybody. This is 2 to the 3 times 2x plus 1 power equals 2 to the negative 2 power. Okay, so now that I have common bases, I can drop the bases. When I do that, I'm going to distribute this. So this is going to give me 6x plus 3 equals negative 2. So 6x equals negative 5, and x equals negative 5/6. All right, next page. All right, so starting in 2018, calculator required. All right, let me go get the calculator up. All right, so starting in 2018, a biologist studied the population of largemouth bass in a particular lake over several years. In 2019, where t equals 1, there were 430 largemouth bass in the lake. Okay, so that tells me that I have an ordered pair that is 1, 430. In 2023, t equals 5, there was 715. So I have an ordered pair of 5, 715. The number of largemouth bass in the lake can be modeled by this function, say natural log function, where L of t is the number of largemouth bass in the lake during year t, and t is the number of years since 2018. So we're going to use the given data to write 2 equations that can be used to find the values for the constants a and b. So I'm using this. I have my 2 ordered pairs. My y value is 430. That's equal to a plus b, which I don't know, times the natural log of 1, and then 715 equals a plus b times the natural log of 5. All right, so I wrote my two equations. That's all that I was asked for. Next, I am asked to find the values of a and b. All right, so as I do this, I can look back up here. Natural log of 1. Remember, this is your parent function. Natural log of 1 is 0. So this whole term here, this b term, that zeroes out, which tells me that 430 equals a. Then I can do 715 equals 430 plus b times the natural log of 5. Okay, so, and guess what? This is a calculator question. Should you be able to subtract this without a calculator? Yes. Should you use the calculator when you're allowed to? Again, yes. So, we're going to get a calculator. I'm going to add a calculator. And I already forgot what I was subtracting. 715 minus 430. That is 285. Okay, so that means I get 285 equals b times the natural log of 5. So b equals 285 divided by the natural log of 5. So that means that b is equal to 285 divided by the natural log of 5. 177.080. 177.080. All right, so there's my A, there's my B. So it says use the given data to find the average rate of change. Okay, average rate of change, that is just slope, of the number of largemouth bass in the lake and the fish per year for, and look, it even gives me the units here in fish per year. From 1 to 5, express your answer as a decimal approximation. Show the computation. So just because you have a calculator, you still got to do your stuff, right? And so this function, this was L. Okay, so that means we're going to do L of 5 minus L of 1 over 5 minus 1. All right, so L of 5 was 715 minus 430 over 4, right? And we already know that this is 285 over 4. Does tell us to give a decimal approximation. So 285 divided by 4. Okay. Oh, well, it would help if I used the right numbers. 285 divided, I was like, why don't I have a decimal? Because I didn't type the right number. I get 71.25. I do not force a third decimal. If that's what you get, that's what you get. And so this equals 71.25 fish per year. Or you can write out per, either way. Then we're going to interpret the meaning of your answer from Roman numeral 1 in the context of the problem. All right, so you first want to decide, is this increasing or decreasing? Your rate of change is positive, which means that the function is increasing, right? So the number of fish is increasing. So I can say then that the population of largemouth bass is increasing at an average rate of 71.25 fish per year from T equals 1 to t equals 5 years. Okay, little side note here. Had this been negative, we would say that it's decreasing, but then this would be a positive number, because when you say it's decreasing, if you're decreasing at a negative amount, then that's a double negative. Okay? So then it says to consider the average rates of change of L from t equals 5 to p years, where p is greater than 5. Are these average rates of change less than or greater than the average rate of change? Okay. I think visually a graph can really help you here. When you have the calculator, you can graph the actual thing if you want to, but you don't need to. Let's go back and just kind of look at what we have. A and B are both positive. So when I substitute it in here, if A and B are both positive, that means I don't have any reflections or anything going on here. So the parent function, even if I don't know like exactly where my x and y intercepts are or whatever, I at least know that the shape looks like this. Okay? Shape looks like that. I mean, it's still a log, right? And so I know that from t equals 1 to t equals 5, okay, it says, is it going to be greater or less than? Well, let's think about what's happening to our rates of change. So let me just put a, I don't know exactly where these numbers are, but like we're going to go from 1 to 5 and then to p, whatever. So this average rate of change is whatever it is. It was a 71.25. But then as I go along and I get closer to p over here, I want to know, are those average rates of change less than or greater than? So let's just start with writing this out. So it says, consider the average rates of change from t equals 5 to t equals p years. Okay, so we can say the average rates of change, just getting this straight from the question, of L from t equals 5 to t equals p years. Oh, let me spell years correctly. Years where p is greater than 5 will be less, okay? Well, let's talk about why less. I should have done that. What's happening to your function? Your function is increasing, right? Your rates of change are positive, positive, getting closer to 0, right? So your rates of change are decreasing. So from here to here is one thing, then as I go along, they're going to be decreasing. Not only because literally the average rates of change are decreasing, but what we know about the function is that it is concave down. So will be less than the average rates of change from t equals 1 to t equals 5 years because L is concave down, therefore average rates of change are decreasing. Lots of words, but it's mainly because we're just kind of copying down the question there, which is the easiest way to do it. All right, next page. All right, table above collected values of the life expectancy in years and income in thousands per year, so we've got to pay attention to that, for individuals around the world. The data in the table can be modeled by this function, okay, where X is the individual income in thousands per year and L is the predicted life expectancy in years. find the equation L of x using the regression features on your graphing calculator. All right, so that means we're going to the calculator. We hit on. We want new. We want no. We are doing regression, so we are adding lists and spreadsheets. Go up and hit X, and then go ahead and type all this in. So we get 2, 7, 10, 15, 18, 20, 25. Well, they're probably much faster on the calculator than I am on this board. Okay, so I come over here, put my Y's in. Five, 75.70, 76.39, 77.85. Oops, not plus. 79.04. Oops, nope. 80.92. Oh, what the heck? What did I do? Oh, Lord, I got off somewhere. All right, hang on. I'm going to pause and figure out what the heck and fix it. Okay, I fixed it. Hopefully you were typing it off your paper and not following me because I missed a couple of X values there. All right, so I have them all typed in. It's literally telling me to do regression, so there's no question here. We just got to know what buttons to push. So I'm going to hit menu, 4 for statistics, 1 for stat calculations, and I want it gave me a natural log, so I want a logarithmic regression, which remember, you got to arrow down to, that is B. Here, I choose my X. Oh my goodness. This board drives me nuts sometimes. Okay, and it was B. All right, so I need to choose X here. I need to choose Y here. Okay, notice it's telling me it's in F1, all right, and then I can just hit enter, and there you go, it gives it to me. So I'm going to arrow up so I can see it all. It reminds me what form it's in. It gives me my, gives me my A and my B. We are writing down 3 decimal places, so we will have L of X equals 56.813 plus 6.533 times the natural log of X. Now, we are not typing that back in, right? It is in F1 for us. If we need to make ourselves a little note, don't forget I'm in F1. All right. In 2009, the United States had a per person income of $41,000 and a life expectancy of 79.43 years. What is the residual of this data using the model found in Part A? Okay, so a couple things. We got to remember what a residual is. The residual is the actual minus the predicted. There we go. All right, which means that I'm going to take the actual life expectancy, which is 79.43, and I'm going to subtract L of, but I'm not putting in 41,000 because remember, this is in thousands of dollars. So 41,000, if I want to talk about it in thousands of dollars, that is 41.25610. And I would use the whole thing that they have there. Okay. All right, so then I'm going to go to my calculator. And I'm going to add a page so I can have the calculator screen. I know it can be graphed for me. I don't really care to look at the graph. So the actual was 79.43 minus, so that L that is in F1 of 41.25610. Hit enter. And I get negative 1.688. That equals negative 1.688. All right. Then it says a given country has an average income of $43,500 according to the model found in A. What is the average life expectancy of an individual from this country? So we want L of, and again, I'm not putting in 43,000. I'm going to put 43.5, and then the zeros there don't really matter. I'm going to go to my calculator. F1 of 43.5. That gives me 81.464, and that is 81.464 years. This is the life expectancy. It's my output. Oh, years. Years. All right. Let's look at 14. As part of a training program, Stacy began working out in an attempt to lower the amount of time it took her to run 1 mile. Initially, T equals 0. It took her 570 seconds to run 1 mile. At the end of each week during the training program, Stacy would run 1 mile and record her time. After 4 weeks, Stacy's time to run 1 mile was 465 seconds. Stacy's time to run 1 mile can be modeled by this function. And notice this is T plus 1, not just T. Where M of T is Stacy's time in seconds for week T, and T is the number of weeks. All right, so we are going to use the given data to write 2 equations that can be used to find the values for the constants A and B in the expression. All right, so that means my ordered pairs here, this was 0, 570, and this one is 4, 465. All right, so I've got my y value, which is 570, that's equal to a plus b, which I don't know, times the natural log of t, which is 0, plus 1. Plus 1. Then I have 465 equals a plus b times the natural log of 4 plus 1. And I would just leave it like that. Okay? We set them up. Now we want to find the values for A and B. Okay, so when I look here, this is going to become, the natural log of 0 would have been problematic, but the natural log of 1 is fine. This term zeroes out again, so I get that 570 equals A. That looks like a 9. It is an A. All right, so then I'm going to substitute that in here, so I get 465 equals 570 plus b times the natural log. I'll go ahead and make that 5. I'm going to use my calculator because this is a calculator question, and I'm going to do 465 minus 570. 465 minus 570. Negative 105. Negative 105 is equal to b times the natural log of 5. So b is equal to negative 105 divided by the natural log of 5. Okay, come back over here. Negative 105 divided by the natural log of 5. Negative 65.240. B equals negative 65 point, I already forgot, 240. Alrighty. Good job, Stacy. Alrighty, here we go. We're going to plot these points. These very interesting graphs here. So 0, 30. Remember, this is 10, 20, 30. 1, 2. This is A. This is B. C is 2 and then 1, 2, 3, 400. Oh, just a little bit. C. D is 3, 1.5. That's D. E is 4, 11. 11 would be like right there. That would be E. There you go. Okay. It says the grid above is a semi-log plot with the vertical axis logarithmically scaled. Plot the following points on the same coordinate plane above. Okay, so let's talk about this scaling real quick. So it's logarithmically scaled because this is 3 to the first, this is 3 to the second, this is 3 to the third, and this is 3 to the fourth. Okay? So if you notice how things are scaled, this is 1, 2, 3. This would be 3, 6, 9, 9, 18, 27, 27, 54, 81. That's what's happening there. Okay, so let's plot these. 0, 2. So 0, 2 is right here. That's A. B would be 10, 18. So 10, remember this is 9 and then 18. So this is my B. C is 20 and then 6. So this is 3, 6 before we get to 9. That is C. 30 and 12. Okay, so we got 30. So this is 9 and then 18. And so 12 would be right about there. B. And then 40, 1.5. So remember this is 2, so 1.5 right about there. Okay, and that is your E. Okay. Now, again, logarithmically scaled. We have e to the first, e to the second, e to the third, e to the fourth. All right? So this says, the function f is graphed on the semi-log plot above where the vertical axis has been logarithmically scaled, vertical axis. Which of the following could be a model for f? Okay, so remember, one of the things that we want to figure out here, that we want to be able to recognize rather, is that if this is linear on a logarithmically scaled graph, then your function is going to be exponential, which means I can mark this one out, and I can mark, well, that's the only one I can mark out right now, right? So let's see if we can figure out any of the rest of these. So this is 0, and then something less than e. Remember, e is about 2.7. If I substitute 0 in here, e to the 0 power is 1. So this would actually give me 3 if I substituted in 0. So f of 0 would be 3. And I know e is about 2.7 something, so that one doesn't work. If I substitute 0 in here, I would get 2. So here f of 0 gives me 2 because e to the 0 power is 1. This f of 0 would also give me 2, so that doesn't really help me any. So maybe here is where we want to be able to actually figure some of this out. So for C, let's say that this is y equals 2e to the x power. Now I'm going to take the natural log of both sides. So the natural log of y equals the natural log of 2 to the e to the x power. 2 times e, rather. So that means that the natural log of y is equal to the natural log of 2 plus x times the natural log of e. So that just gives me the natural log of y equals the natural log of 2 plus x. All right. So now let's do that for D as well. This gives me y equals 2 times e to the negative x power. So natural log of y equals the natural log of 2 times e to the negative x power. Natural log of y, which are these y values, equals the natural log of 2 plus, well, if I bring that negative x out front, I can say minus x times the natural log of e. And so then the natural log of y is equal to the natural log of 2 minus x. Okay, so we just linearized the exponential functions that were our answer choices. Okay, these equations represent the equation of the line that would come from this. I can clearly see that this line has a positive slope. This one has a positive slope. This one has a negative slope. That is what makes my answer C. All right. Now let's look at this one. It says a set of data is shown in the semi-log plot above. If an exponential regression is used, okay, exponential regression is used to model the data, which of the following claim and explanation statement best fit these data? Okay, so remember, a semi-log plot, if the data appears to be linear, then it would be exponential. So this, oh, well, my board jumped. Hang on, let me try that again. I kind of missed that one, but that does not appear to be linear. There is definitely a curve there, okay? So I would say that the exponential model is not appropriate. So we have 2 that say it is, 2 that say it's not. So I'm going to eliminate A and B. Then it talks about the residual plots. Okay, so remember the R values. This is a semi-log plot. The R values that we plotted, they look like this. Remember, we have some above, some below. And if we saw a clear pattern, that like something like that, then that would mean that that was not a good model. If it was random, then that means that there is no pattern. So since it's not appropriate, we should have a clear pattern. Because a pattern means it doesn't work. A no pattern means that it does. All right. Oop, that was it. All right. So make sure that you come prepared for this test tomorrow. We have reviewed for quite a while. Hopefully you have all of your assignments done and you are ready to come and do well.